Okay, so the live stream should be going. There we go. All right, and what we're gonna do is we are going to go over some really basic electricity formulas. So I want to make sure that all this is gone. Get rid of all that. Switch it back. Okie dokie. So these equations here are the ones that I would highly recommend that you guys write down. So the very first one, excuse me, is going to be voltage is equal to current times resistance. This is voltage, this is current, and this is resistance. Voltage has units of volts. Leo's here. All right, give me 1 second. Need to get him. Yo. Okay. Sure. Okay. Okay, so just so you're aware, I am live streaming, so make sure it's appropriate. I would say Chinese food. I had Chinese food last night and it was delicious. Okay. I will accept that responsibility. Okay, so when it comes to voltage, we have obviously units of volts. When it comes to current, we have units of amps. So that's just a shorthand for ampere. And then resistance, we have the units of ohms. Ohm. And this symbol is the omega symbol. So it's the Greek symbol omega. Ohm, omega. And then we're going to be dealing with power, and that's going to be in units of watts. Okay. So this first equation, V equals IR, the two subsequent equations that you can get from this, from like specifically this one here, you have V equals IR, and then you have I is equal to V over R. And then you also have R is equal to V over I. Okay, so those are the three basic equations here. Cool. So you guys may not need those like written down, because I'm sure that being that you guys are honor students, you can take this equation and solve, like this one's already solved for voltage. You can hopefully solve for I and R respectively. Cool. Then there's these two equations dealing with power. One way that we can write it is power is equal to current times voltage, or it can be power is equal to my current squared times my resistance. Cool. Can we make the triangle? Oh, yes. I gotta remember how to do that. In the Trayon, and so we're just missing Iverson and India, right? Yeah. Yeah, Trinity, I just got you. I got you for attendance. Stuart, can you remind me how the triangle looks? Be at the top. R. It's not a triangle. Come on, Applewhite. Like that. And then it's kind of split like this. Okay. So if I'm solving for V, it's just going to be I times R. And then if I'm solving for I, it's going to be V over R, right? Yeah. And then if I'm solving for R, it's going to be V over I. Does that make sense? So let me put that over here. Make that a little bit bigger. Mm-hmm. Yeah. So remember yesterday or last class we went and did the quizzes thing. So we did this little quizzes thing, and then the some of the questions had some like equations that you needed to know, and this is as far as we've gotten. Like I've been kind of explaining the equations. Does that help? Okay. All right. So does everybody know how to use this triangle? So if I wanted to solve for I, it would be I is equal to V over R. If instead I wanted to solve for R, it would be V over I. And if I wanted to solve for V, it's just I times R. Cool. All right. All right. So if I wanted, like, this would be the same kind of deal, solving for I and V. I will write this one. So if I wanted to solve for R, it would be P over I squared. And let me do the thinner blue. Solving for R, it's going to be the power over my current squared. And then if I was trying to solve for current, this would be P over R all under the square root. Cool. So I am going to have a little formula sheet that has all 9 iterations of this. So it'll have this equation solve for V, I, and R. This one will be power, current, and voltage. And then here would be power, current, and resistance. And I'll have it all listed out for you. Okay, so having those equations, do I need to pause it so you guys can do a screenshot? And I'll do that. All right, so I'll have it. Leo. All right, so 3, 2, 1. Now we're gonna move on. All right. So when we solve these problems, I would definitely recommend doing your knowns and your find. Okay. So I'm gonna do. Oops. My goodness. Trying to be fancy, but it's going to be a waste of time. All right, so we have our find, and then our nodes. Okay. So in this problem, if a battery produces 12.6 volts, and what would be, if the battery produced 12.6 volts, there shouldn't be an and there. What would the current flow be for a 6 ohm resistor? Okay, so we're asked to find the current. So we need to find I for current. And that's going to be in units of amps. Actually, let's do the thinner one. The current. Then you have amps. And then we know the voltage is 12.6 volts. 12.6. And then the resistance was 6 ohms. All right, so I'm solving for I, and I am given V, and I'm given R. So we're going to be using this first equation. So V equals I times R. I'm asked to solve for a current. So we end up getting current equals V over R. My voltage is 12.6 divided by 6, and that's going to be approximately 2.1 amps. Cool. All right. .1 amps. Any questions so far? Okie dokie. Now we're going to go to the next one. So what voltage is needed? So we need to find volts. And that has units of volts. Oh, okay. Bye, Trinity. And 2 amps. So I know my current is equal to 2 amperes through a 10 ohm resistor. So resistance is 10 ohms. So I'm solving for my voltage. So it's just going to be V equals I times R. And current is 2, resistance is 10, 2 times 10, and I get 20. Cool. Okay. Now I know, even though you guys are honor students, this may seem a little redundant, a little too elementary, but this is also for people like I'm doing this so my other classes can also have more examples. What is the resistance? So we're solving for R. And that needs to be in ohms. I cannot draw my omegas correctly today. If you don't use a GFS chart, no. If you're in class, then yes, definitely. All right, and then we have a 2 or a 20 amp current. So current is equal to 20 amps, and then a 100-volt battery. The voltage is equal to 100 volts. So I'm solving for R. My equation is V equals current times resistance. I'm solving for R. So R is equal to V over I. My voltage is 100. My current is 20. So 100 divided by 20, and it's supposed to be in ohms. I get 5 ohms. Cool. Easy peasy lemon squeezy. All right, so this one's saying, what is the power? So we're solving for P. And that is in units of watts. Watt? So 20 volts and 5 amps. So voltage is 20 volts and current is equal to 5 amps. So the equation that has current, voltage, and power is this one. So power is equal to current times voltage. So I don't need to do any algebra. My current is 5. My voltage is 20. And this is going to give us 100. So 100 watts. No, this is like what I was just saying. Like, if this feels elementary, like, don't take it as an insult. Like, this is supposed to be very easy. That's why I kind of wanted to do this kind of instead. I wanted to move to electricity instead of doing like Snell's law and the lenses stuff, because that's pretty intense. And it's near the end of the school year, and we've had a long, stressful year. So I'm going to kind of keep it a little bit easy. Alrighty. So what is the current through a, should be an 11 volt, and 11, yeah. And 11 volt and an 11 volt. Why do both of those sound weird? An 11 volt, 11 volt. Yeah, I know it's supposed to be and, but that still sounds weird. All right, so what is the current? That's going to be in amps. And we have volts of 11. Yeah, like the word total. If you look at that for too long, it just looks weird. And I know there's a phrase for that too. When you think about something too much, or you look at a written word for too long, it starts to look like it's misspelled, but it's not. It's probably a German phrase for that. Okay, so I'm looking for a current and I'm given voltage of 11 volts and power of 99 watts. I'll go back up to my equations. So P equals IV. Power is equal to current times voltage. That's not a V. That's a V. I'm searching for current. So I have power over voltage. Power is 99. Got 99 problems. It's your boy. And I get 9 amps. I can think about the and it becomes weird. Like who made it? Who made that up? Yeah. There's a bunch of words like that. Or an. Did you guys know that what was the word? It's like some old English. Oh, the I'm tired. So what is the voltage needed to cause 50 amps through 10 ohm resistor? So voltage, current is 50 amps, and resistance is 10 ohms. So this is V equals IR. So it's just gonna be 50 times 10, which is 500. So 500 volts. That one's pretty easy. And if somebody has time, would you mind going on my channel and making sure that my audio is still good? So I had an issue that one time where none of the audio was captured. And that was stupid. All right, the battery produces 12.6 volts. So volts is equal to 12.6. What would be the current flow for it? Wait a minute. Wasn't this the same one? Yeah, because I've already done this one. I don't know how I missed that in the first class. All right, just let me know, Stuart, how my audio is, if you don't mind. Cool, appreciate it. So what would the circuit resistance be if there was a 7.5 amp draw? So current is equal to 7.5 amps, and charging the system of 15 volts. The resistance, so R, it's going to be in ohms. So R, so voltage is equal to current times resistance. I'm searching for R, so R is equal to V over I. My voltage is 15, and my current is 7.5 amps. So 15 divided by 7.5, I get 2. I don't know why I always do that. So that part's flat, and then I always make that first one There we go. That's prettier. 2 ohms. So it's going to be letter D. Cool. Any questions? Comments, concerns? So I plan on doing like creating a Canvas quiz that has this kind of stuff in it, where you guys will have examples of like I'll have one of each of the different equations where it's solved for V, I, R, or P, and you're gonna have to kind of like with the energy worksheets that we had before at the beginning of the third 9 weeks. I'll give you a sheet, and you're gonna have to use one of the like all 9 of the equations one time, and I'll make it so you guys can have unlimited attempts at it, so you guys can practice. And then there's gonna be some like conceptual questions, and I think what we will do next class is I'll have a thing where I talk about just the basic concepts, and have that recorded since we've already gone through all the other videos. I also want to record a lesson where I'm covering all the basic materials or basic concepts. Cool. So I'm going to go ahead and... Huh? What do you mean colorful? Oh, in the video? So it looks fine on my screen. I don't like I was messing with the color. So what about let's see. I was messing with the settings earlier. Like around here? Is that the case for everybody? Or is that just him? Might be. Okay. Yeah, it looks fine on my end, and when I pull up the live stream, it looks fine over there too. So I think it's just on you, bro. All right, let me go and end that. So stop. Whoops.